Okay, so hi, this is me going through work solutions for higher maths. It's the specimen paper that I'm going through this time. You can get it on the SQ website. I'll put a link to the paper in the kind of description. So, we'll start with question 1. So this is an integration question. So we've been asked to find the integral of 3x cubed plus 1 over 2x squared with respect to x. So before we can integrate, we need to prepare this for integration. The first thing I would do is you can split up the fraction, because we know that if we've got anything over one denominator, we can split it so we get it like this. So we've got the 3x cubed over 2x squared plus 1 over 2x squared. We can't integrate when we've got x squared on the bottom, so we need to combine the indices. So we're using our indices laws that we learnt at National 5. So we know that we can leave the 3 over 2, and then we've got x cubed divided by x squared, so we subtract the powers, so we just get x. And then this one we've got the half, and then we've got x squared on the bottom. If we move it up to the top, the index becomes negative, so we get x to the minus 2, and then we've got to integrate that with respect to dx. Now we're ready to integrate. So when we integrate, what we do is we raise the power of our letter so that x becomes x squared, and then we divide by that new power. So we've got 3 over 2, and we've still got that, we've got that extra 2 we need to divide by, so we can put that on the same fraction. And now we need to do the same, so we raise the power, so from minus 2 to minus 1, and then we have to divide by the new power, so the minus 1. Then we need to add our constant of integration. So if we kind of just tidy up a little bit, we get 3/4 x squared plus, and then here we've got, on the bottom we've got the 2 times minus 1, so that's actually going to give us minus 2, so we don't want that plus. We want it to be take away, and then we've got the half, we have x to the minus 1, and then we've got our constant of integration. Okay, so for this, the marks that you get are for preparing for integration. So when you get to this point, you get your marks. You've known how to prepare for the integration. When you correctly integrate the first term, you get a mark in there. You get a mark for correctly integrating the second term, and then your last mark for this question comes from including a constant of integration. So the final line with the constant of integration gives you that 4th mark for the first question. So now let's move on to question 2. Okay, so for question 2, we've got the equation of a curve and the equation of a line, and we need to find the point of intersection. So the first thing we need to do is equate the two equations we've got. We have to equate them. So we have y equals and y equals, so we can set them equal to each other. So we're going to have x cubed minus 2x squared plus x plus 4 is equal to 4x plus 4. Okay, so to find the points of intersection, we need to equate this equal to 0 and solve to find the x values. So we move the 4x plus 4 across to the other side of the equation. So our x cubed is going to stay, our minus 2x squared is still the same, and then we're going to have plus x take away 4x, which gives us negative 3x, and then we've got plus 4, so plus 4 on one side, plus 4 on the other, so we're going to take one of them across, which will make it 0, so we get x cubed minus 2x squared minus 3x equals 0. So we need to factorise this to find our values for x. So not forgetting that the first kind of factorising we always need to look for is a common factor, and all of these terms have an x in them, so we can just take x out as our common factor to start with, getting left with x squared minus 2x minus 3, and that's still equal to 0. So now we've got a trinomial in our bracket, so we can factorise that into 2 brackets. So we've got x squared, so in the front of our brackets we're going to have x and x. The last term here, we've got minus 3, So we're going to either have to have minus 3 and 1 in the end of our brackets, or 1 and minus 3. But if we look, we've got to get minus 2x here. So it's going to have to be minus 3 plus 1 to get that minus 2. So now we've done that, we need to solve this for 0. So each of these could be equal to 0. So we have x equals 0, or x minus 3 equals 0, or x plus 1 equals 0. So we've got x equals 0, this is going to give us x equals 3, and that's going to give us x equals minus 1. So it's asked us for coordinates, so we can't just stop there. We need to find the y values. We could put it into the equation of the curve, but that's a very long equation. We've got quite a short, nice equation of y equals 4x plus 4. So if we put y equals 4x plus 4 with x equals 0, we put that into here. We're going to get 0 when we do 4 times 0 plus 4. So when x equals 0, y equals 4. So that gives us the coordinate 0, 4. The next one, so we take the x equals 3, put it into here. So we get 4 times 3, which is 12, plus 4, so we get 16. So we're going to have y equals 16. So we get the coordinate 3, 16. And then our last one, we've got the minus 1. We put the minus 1 in here. And we end up with 4 times minus 1, which is minus 4. Add this 4, which becomes 0. So we have y equals 0. So we've got minus 1, 0. So for this question, our marks are for knowing to equate and set them equal to each other, for rearranging equal to 0, for fully factorising, and then calculating all the x coordinates, and then calculating all the y coordinates. Okay, on to question 3. Okay, so question 3 is vectors. We've got mixed in with a bit coordinates, so we've got a line where we've got P, Q, R and S. We've got the coordinate for P. We've been told the vector for PQ and the relationship between PQ, QR and RS. So first thing I would do with this question is we know that PQ is 6i 12j minus 6k. So change that into a column vector and get 6, 12 and minus 6. So we know from here that PQ is 2QR. So you can find QR from here. So we know if it's PQ is twice QR, then QR is going to be half of PQ. So that gives us half of 6, which is 3, half of 12, which is 6, and half of minus 6, which is minus 3. And then we can go on as well with RS. And with RS, we know that PQ is 3RS, so that means RS is 1/3 of PQ, so we can divide it by 3. So if we look at PQ, we've got 6 divided by 3, which is 2, 12 divided by 3, which is 4, and then minus 6 divided by 3, which is minus 2. Okay, so we've used all our information, we've got everything we need from there. We know our vectors for each of our parts, but we've been asked to find the coordinate of S, so that's the point right at the end. So the first thing we need to do is find the coordinates for Q. And with any vector, if we've got kind of a vector AB, we know that that is B minus A. Yeah? So we can kind of rearrange, so we're trying to find the second letter in this, so that's the B. So we know that B is going to be AB plus A. So we can do that for each kind of step. So we know that Q is going to be PQ plus P. So then we've got PQ, which we know is 6, 12 and minus 6. And we've got the coordinate for P, and we can write that kind of as a column vector. So we get minus 6, we get 3, and we get 9. I'm going to add them. We add them, the x's, then the y's, then the z's. So we've got the 6 add minus 6, which gives us 0. We've got the 12 add 3, which gives us 15. And then we've got the minus 6 add 9, which gives us 3. So we've found Q. Now we have to use Q to find R. So it's the same kind of principle as what we've got here. We're trying to find the second letter, so we can use the same method. So we've got to find R, which is going to be QR plus Q. So we know that Q is 0, 15 and 3, and we've got QR, which is 3, 6 and minus 3, and then again we just add them together, so we're going to get 3, we're going to get here, that's a 6, so we've got 21, and then we're going to get 0 on the bottom because we've got 3 and minus 3. And then we can do this, our last step, to get S, which is going to be RS plus R. So we've got RS, which is 2, 4, minus 2. We've got R, which we've got is 3, 21 and 0. So we add them together, and we're going to get 5. We're going to get 25, and we're going to get minus 2. And we can write that as a coordinate because it's asked for a coordinate. So we have S is equal to, and then we have 5, 25, minus 2. So for this question, your marks are for knowing to find the coordinate of Q or the components of Q, so this bit here. You get another mark for setting up the vector for equation R, so kind of this part here. And then one for finding the coordinate once you've done that. You get one for setting up S, and then one for finding the coordinate of S at the end. So that's a 5-mark question, and that's us. So now we'll move on to question 4. Okay, question 4, we've got, given that 2x squared plus px plus p plus 6 equals 0 has no real roots, find the range of values for p, where p is a member of real numbers. Okay, so if we look at the equation, so we've got 2x squared plus px plus p plus 6 equals 0. So we should know that the part of the question that says has no real roots, that's telling us something really specific, and that's to do with the discriminant. And we know that anything with a discriminant which is less than 0 that's what the no real roots means. So it means the discriminant is less than 0. And the discriminant is b squared minus 4ac. So we know that that's got to be less than 0. So we need our a, our b, and our c values. So our a is the coefficient of the x squared, so the number in front of the x squared, so that's 2. Our b is the coefficient of the x term, so that is p. And our c is anything else left over. So it's all the stuff that's not got any x's in it, so it's the p plus the 6. Being careful that we don't just do the p or the 6, it's both of them together, so it's everything. So we then can substitute those in to our b squared minus 4ac is less than 0. So we're going to have p squared minus 4 times 2 times p plus 6, and that's got to be less than 0. So we kind of tidy this all up. We've got p squared is less than, and then the 4 and the 2 give us an 8, and then we times that 8 through by a bracket, so we get 8p, and because it's negative, and then we've got 8 times 6, which is minus 48, because it's minus 8 times 6, and we've got that that's less than 0. So now we have something that looks a lot like a trinomial, so we can factorize it to find our values for p, and it's less than 0. So if we look, we're going to have, so because we've got p squared, we've got to have p at the front, p at the back. We have 48 minus 48, so we need two numbers that multiply to give us minus 48 and add to give us minus 8. So we know, because the only way to multiply to get a negative is to multiply a negative and a positive. And then we've got to pick two numbers. So if we look at 48, so we can split 48 up into 1 and 48, 2 and 24. We've got 4 and 12. We have 6 and 8, and that's it. So we need to get 8 from these. So the only pair that's going to work to give us an 8 is going to be the 4 and the 12, if we kind of add them together or subtract them. It's the only thing we can do. So we need minus 8. So to get those, we're going to have to take away 12 and add 4. So we can put those in. So we get minus 12, add 4. So if we think about this in terms of the graph of our thing, because we're trying to find the values of this graph, where that's the case. So if we look from our roots that we've got kind of here, we've got p minus 12, p plus 4. So we know that if we drew the graph, the roots are going to have to be minus 4 and plus 12. And we're looking for where that graph is less than 0. So that graph is less than 0, kind of in this bit here. So that's between the values of minus 4 and 12 is where it's negative, because that's where it's below the graph, or below the axis. So we then need to write out our values for, or the range of values for p. So we've got our p, and we know that it's got to be between those two values. So we know it's got to be less than 12, and we know that it's got to be more than negative 4. So it's got to be more than negative 4, and that gives us our answer. So p for this, for it to be a member of the real numbers, to give you no real roots, has to be between negative 4 and 12. So the marks for this question are for knowing that to use that the discriminant is less than 0. That's 1 mark, and knowing your A, B and your C. So your second mark is for simplifying, so kind of getting to this point. You get 1 for factorising the left hand side, and then knowing and kind of stating the correct range gets you your final mark for this question. Right, so looking at question 5, we've got line L1 has the equation given. We know that the second line is perpendicular, so we need to find the gradient. So looking at part A. So the first thing is, what do we know about lines that are perpendicular? So if we've got two lines that are perpendicular, so that means at right angles, we know that the gradients of the first line times the gradient of the second line give us minus 1. So the two perpendicular lines, if we multiply the gradients together, we get minus 1. So we've got to find the gradient of the first line, so line 1, to be able to find the equation or the gradient of the second one. So to find the gradient, we need to change that formula into this form. So the y equals mx plus c, and that's the only way that we can read the gradient. So we've got the square root of 3y minus x is equal to 0. So we are going to have to add x to both sides, so we're going to get the square root of 3y equals x, and then we're going to get y is equal to 1 over root 3 times x. So with our perpendicular lines, we know that the gradients must multiply together to get negative 1. So the only way to do that, so the m is 1 over root 3. So the gradient of line 2, they must multiply together to give us negative 1. So the only way to do that is it's going to have to be negative, and to get negative 1 it's going to be negative root 3, because if we times those two, if we times 1 over root 3 and negative root 3 together, we're going to get minus 1. So B. So we've got a line and we're trying to find the angle that it makes with the positive direction of the x-axis. So we know that m equals tan theta, so that's what we've got. So we're going to be using this. We know that our gradient is negative root 3 and that we have tan theta. So to get the angle, we do tan to the minus 1 of negative root 3. But we know that we can't do tan of negative numbers and get our answer, so we kind of go back to the cast diagram from National 5. So we know that the line, so it's from the positive x-axis, so we know we're going kind of round this way from the x-axis. So our line is going to be something like that, so it's going to be more than 90. So we need to find the relative acute angle like we did before. So that's tan to the minus 1 of root 3, which we know is 60 from our kind of diagrams, or from our, if we do like these, like the 1, 2, root 3, the kind of triangles, the exact value triangles, we know that this one is 60, that one's 30, because it's the tan, so it's going to be opposite over adjacent, so it's going to be the 60. And then because it's in the second quadrant, because that's the only one it can be, it can't be in the bottom two because we're going round from the x-axis across, so that's where we do 180, take away that, So it's going to be 180 take away 60, which gives us our answer of 120 degrees. So for this question, the marks for part A were for finding the equation of the first line and then calculating the gradient of the second. Then you got 1 for putting in m equals tan theta and substituting in, so this line here. And then your last mark is for the answer, so the 120 degrees. And if you have used radians, that's fine, don't lose any marks. Okay, question 6. So we have to start by finding an equivalent expression for sine of x plus 60. So we have sine and we've got x plus 60. So from our formula sheet at the start of our exam paper, we have that sine a plus or minus b is equal to sine a cos b plus or minus cos a sine b. So that's what we're going to have to use here. So just kind of straight from there we can use this. So our x is our a and our 60 is our b. So it's going to be sine x cos 60 plus cos x sine of 60. Right. So we now have to, for part 2, we need to hence or otherwise determine the exact value of sine 105. So a way to do this is we know that 105, we've got that 60, so 105 we can split up as being 45 add 60. So we can use this formula we found there to do this. So we're going to have sine of 105 degrees, which is equal to the sine of 45 plus 60. So that's going to be the sine of 45 times the cos of 60 plus the cos of 45 times by the sine of 60. So this is a non-calculator paper, we don't have a calculator, so we need to do exact values for this. So if we quickly kind of draw our exact value triangles, we have the one that's 1, 1 and root 2, and both the angles are 45 degrees. And then we've got, same as the last question, we've got the one that's 1, 2, root 3, that one's 60, and that one's 30. We need to know the sine of 45 and the cos of 45, and we need to know the sine of 60 and the cos of 60. So we know that sine is opposite over hypotenuse, so that's going to be 1 over root 2. Cos is adjacent over the hypotenuse, so that's still 1 over root 2, so it's the same for both of those. And then we've got sine of 60, sine is opposite over hypotenuse, so we get root 3 over 2. And cos of 60 is the adjacent over the hypotenuse, so that's going to be a half. So we can put these in, substitute in, we get 1 over root 2 times by a half, plus, and then cos of 45, 1 over root 2, times by root 3 over 2. So if we kind of put those in, we're going to get both of them, so we're going to end up with 1 over 2 root 2, plus root 3 over 2 root 2. And then, because they've both got the same denominator, we can put it together, so we get 1 plus root 3 all over 2 root 2. And for this question, your marks were for the first one, so correct expansion gets you the mark. And then you get a mark for any equivalent expression, so this one works. You get 1 for correct exact value equivalent, so putting in your exact values correctly, and then you get 1 for your answer. So for question 7, we have to show that x plus 1 is a factor of x cubed minus 13x minus 12. That is going to be synthetic division, so we are going to have x plus 1 is, if we're trying to have x plus 1 as a factor, that means we have to do synthetic division using minus 1. So we then set up our synthetic division, it's part A. So we have a coefficient of x cubed, which is 1. We have a coefficient of x squared, which is 0. Don't forget, even though you've not got an x squared there, you can't forget it in your synthetic division. We've got an x coefficient of minus 13, and then we've got our number on the end, which is minus 12. So synthetic division, the 1 comes down. We multiply the 1 by the minus 1, and that goes in here. We add those together, we get minus 1 in there. Then we times the minus 1 and the minus 1 to give 1, which goes in here. We add those together, we get minus 12. We've got minus 12 times minus 1, which is 12. And then we add those together and we get 0. So because we've got 0, that means it is a factor, but we need to write that down or we don't get the mark for the last bit. We can have the synthetic division completely correct, but if you've not actually written down that it is a factor because the remainder is 0, you won't get that mark. So you need to write x plus 1 is a factor as the remainder is 0. Okay, so part B, so we have to factorise it fully. So we know that that is a factor, so we can start. We've got x cubed minus 13x minus 12. And that's going to be equal to, so we've got x plus 1 as one of our brackets, and then we use our remainders, or the information from the synthetic division. So we're going to have x squared minus x minus 12. And that's the numbers that we've got here. So that's our x squared term, our x term, and our number. So now we need to factorise this term here. So our x squared minus x minus 12 to factorise fully. So we're going to have x plus 1, and that's a trinomial. So it's going to go into two brackets because we have x squared here at the front of both of our brackets. We're going to have an x because they multiply to give us the x squared. And then we've got to get minus 12 to get 1. So the factors of minus 12 that are going to work to give us 1 have got to be 3 and 4. Because it's minus 1, it's going to have to be minus 4 and plus 3. So we have minus 4 and we have plus 3. And that's us fully done. It's all factorised in brackets, nothing more we can do. So we've got the marks for here. The first mark is for knowing that it's minus 1 in here. The second mark is for completing your synthetic division correctly. And then your third mark for the first part is for writing that x plus 1 is a factor, so the remainder is 0. You can't get that last mark, can't make it any more strongly to you, but you don't get that mark if you haven't got that written down explicitly. Like just having the 0 here doesn't tell them enough. You need to have it written down as a sentence. So, and then the last part, second part, you get 1 for being able to take that out, identifying the quotient, so from the synthetic division, and then you get your last mark for fully factorising correctly. Right, question 8. So we've got f of x and we have g of x. They're functions, we've been given them, and for part A, we have been asked to find h of x. And h of x is equal to g of f of x. Okay, one of the mistakes that comes in quite often, or that I've heard when looking through kind of marking stuff, is that people get these the wrong way round. So the important thing to do, and quite a good step to put, is put g and then put in the f of x. So we've got 1 minus a half x. So that means everywhere in the formula of g where you've got the x, you have to put that in. So you've got 8, and then you've got the 1 minus a half x squared, and then you've got the minus 3. So we've got to be able to square the brackets. So we've got 8, we leave that for now. So when we're squaring these, we square the 1 at the front, we square the minus a half x. So a half times a half is a quarter, but it's a negative a half and a negative half, so it's going to be plus a quarter, and then we times the x's, we get x squared. And then when we times these two together, to get the middle, so we times these two together, we get what's in the middle, and then we have to double it, and that gives us minus x, because it's a half x plus a half x, so that's minus x, and then we've got that minus 3. So now we need to kind of simplify it and get it. It said show that, so we need to show that, so we need to write it and get it to that exact same way to get that mark. So we times it out, so we've got 8 times 1, so we have 8, and then we've got 8 times minus x, so we have minus 8x, and then we've got 8 times a quarter x, which is going to be plus 2, and it's x squared, not x, and then we've got our minus 3. So we simplify and put it in the right order. We get 2x squared minus 8x, and then we've got plus 8 minus 3, so we're going to have plus 5, and that's shown exactly how they've got it in the question. So that's us done with that bit. So we need to express h of x in the form of a x plus p squared plus q. So this is completing the square. So we have h of x. So we need to take out, because we've got that a in front, we can take out a common factor. So we take the common factor out of the first two, and we get 2 x squared minus 4x plus 5. Because we can take the common factor out of just a couple of the things, it doesn't have to be the whole thing. And we know that both the 8 and the 2 are in the 2 times table, so that's why we can take the 2 out as the common factor. So now we've got the 2 outside, and we need to complete the square, but don't forget that that 2 is multiplying this whole thing. So we're still going to have the x minus 2 because we half it to complete the square, and then we have to subtract the negative 2 squared, and then we've got the plus 5. So we're going to have 2 and then kind of times by the x minus 2 squared. The minus 2 squared gives us 4, and then we're subtracting the 4 and we're adding the 5, but we still need to multiply that all by 2 again. So we get 2, and then we've got x minus 2 squared minus 8 plus 5. So we've got 2 x minus 2 squared, and then it's going to be minus 3. So don't forget this bit. For this question, I think the most difficult part is remembering that this 2 is multiplying everything, so you kind of have to put that extra big bracket to remind yourself, because you've got to times the 2 by the minus 4 to get the right answer. Okay, so quickly going over the marks for this before we move on to part C and D. So you get a mark for part A for substituting in correctly here. You get a mark for being able to square the brackets properly, and then expanding and simplifying and getting to what you've been given in the question. Okay, and then for part B, you get your first mark for identifying the common factor, so the 2, and then you get the next mark for completing the square, and then you get the last mark for processing through to get the plus q or the minus 3 on the end. Right, so looking at parts C and D. So part C, do it under here, so hence or otherwise state the coordinate of the turning point on the graph. So if we look at this, we know from completing the square that the turning point is going to be minus p q. This is from National 5 that we've had this. So we take the p value that we've got kind of from the equation, so that's minus 2, and we have to change the sign of it. So that is going to be 2, and we know that q is going to stay the same, so that's going to be minus 3. So we've now got lots of stuff that's going to help us be able to draw this graph. So here we go. So for part D, we have to sketch the graph of y equals h x plus 3. So that plus 3 is just moving the graph up our axes. So we know here, if we think about just h of x, so if we draw this, h of x is going to be a parabola where our minimum point is 2 minus 3. So that's kind of h of x. So, but we know we're trying to draw h of x plus 3. So if we move this up 3, our turning point, our minimum, is going to be on the axis at 2. The graph shape is going to stay the same, so we know it's going to be like this. And one of the things it's asked us in the question is to show clear the coordinate of the turning point and the y-axis intercept. So we need to annotate the graph. So in here we can kind of write turning point is at 2, 0. And then we kind of substitute in to our formula, so that's our x, that's our y. So if we substitute in x is 0 and we find what our y would be, so if we do that for the original equation, so we have h of x, if we put in 0 straight from the start, like the original version, so we put 2 times 0 squared minus 8 times 0 plus 5, so it would be 5. So that's kind of when x is 0. So we know that if we've got h of x plus 3, then our value for that has got to be 8. So we can mark the 8 because we've added the 3 on, and that's fine. So the marks for these last ones, just stating the turning point gets you the mark. A parabola with the minimum turning point labelled gets you the first one, as long as the minimum turning point is consistent with what you've got before. And then you need to have the 8 on there. So question 9 part A, we've got the equation of a line and we have to find the equation of a line that is parallel to it. So that first equation we need to kind of rearrange, same as we did to get our gradient. So we need to rearrange it into y equals mx plus c. And when we do that, we're going to get y is equal to negative 3x plus 25, because we've just taken the 3x from both sides. So we know that the gradient is minus 3. And then we can put that into y minus b equals m of x minus a. So our b is our y value, so we have the minus 1 and the 10. So that's our a, that's our b. So we get minus 10 equals minus 3 times x plus 1, because it's minus 1, so it just becomes plus 1. So at this point, you don't actually need to multiply anything else out, but kind of for later use, it's better to kind of multiply this out at this point. So we get minus 10, minus 3x, minus 3, and then just kind of simplify. So y equals minus 3 plus 7, and don't forget the x in there like I did. So looking at part B, a sketch is probably going to help us out. So if we draw roughly the line AB, we know the line has a negative gradient, so we can kind of just draw it really roughly like this. We have AB, and we know that this here is minus 1, 10. And the coordinate for B is what we want to find. We've got the equation of a line that's a perpendicular bisector. So if we can find the kind of point in the middle where those two lines meet, we then use that, and kind of that's halfway in between, so we can use a stepping out method or any other method we want, like the midpoint formula, to find the coordinates of B. So the first thing we need to do is to find that point where they meet. So equating these two lines is going to be best. So we can use either simultaneous equations, or we could substitute them in. Personally, my preference is to substitute it in. We've got y, what y is equal to, so we can just substitute that in. So we've got 3y is equal to x plus 11. So we're going to get 3, and then we put in the y, so we get minus 3x plus 7, and that is equal to x plus 11. And then we can multiply out our brackets, so we're going to get minus 9x plus 21 equals x plus 11. Add the 9x to both sides, we get 10x. Subtract 11 from both sides, and you get 10. So you get x is equal to 1. And then we can find the y value by putting it in to our first equation. So we know our equation for y, which is minus 3x plus 7. So we put in that 1 into there, so we get minus 3 times 1 plus 7. So that's minus 3 plus 7, which is 4. And so that's our midpoint, and so we know that it's going to be 1, 4. So again, I'm kind of going to sketch this out as a little thing for stepping out. It's a method that I think is the easiest and the most kind of straightforward and visual, and works for me. Hopefully it'll help you too. So we've got A there, we've got B there, and we've got the midpoint in the middle. So we've got minus 1, 10. We have 1, 4, then we're trying to find B. So if we kind of draw these little triangles, it's been told, because it's a perpendicular bisector, we know these triangles have got the same lengths. So in the y direction, so from 10 down to 4, that should be 6. And then from -1 to 1 is 2. So as you can see, this is not to scale whatsoever, but that's fine, it doesn't need to be. And that follows on the second one too, so that's 6 and that's 2 as well. So you can see for B, we are going to be going down 6 in the y direction. So 6 from the 4 is going to give us -2. And then in the x direction we're adding 2, which gives us 3. So you have B is 3 minus 2, and that's us. And that's much quicker than using the midpoint formula, and it also means we don't need to remember the midpoint formula because we're not given it. Okay, so for this one, you get your first mark in the first part. It's only worth 1 mark, and that's for putting it into the equation. The second one, if you use simultaneous equations or something, that's fine, showing that you know you've got to put them equal, that gets you 1. You get a mark for either getting the x or the y, depending which way you do it. You get 1 mark for the midpoint and finding both coordinates. You get 1 point for either the method for either using the midpoint formula or for stepping out, so that method there. And you get your last coordinate for finding B. Don't forget, if you do use the kind of step out method, draw it down. There's nothing wrong with little diagrams and sketches, it's really helpful. Okay, right, so we've got to find the rate of change of this function. Rate of change just means differentiate, that's all we need to do. So we've got f of x, and that is 4 sine cubed x. So here, because we've got sine cubed, that means we're going to have to be using the chain rule. So we differentiate, so we're finding f dash of x. So we differentiate like we would normally do. So we take down the power, so we've got that 3, we times it by the 4 sine, and then we take down the power, which is going to be 2x. And then we have to multiply by cos of x, because sine of x goes to cos of x when we differentiate it. So that's us differentiated. So now we have to find that value of the rate of change when x is 5 pi over 6. So we've got f dash of 5 pi over 6. And we kind of simplify that, we get that 12 sine squared x times by cos of x. So we need to find out the cos and the sine of 5 pi over 6. So pi over 6, if you think that pi is 180 degrees, so if we split that into 6, each kind of bit has got to be 30 degrees because they're all the same. So if we've got 5 of those, we know that we're actually kind of working at that it's the same as, so 5 pi over 6 is just the same as 150 degrees. So if we know the sine and the cos of 150 degrees, we can find the sine and the cos of 5 pi over 6. So 30 degrees, that's going to be our triangle. So we've got 60, we've got 30, and or we have pi over 6, and we've got pi over 3 if we're using radians. We have 2 here, we've got root 3, and we have 1. So the 150 is the 30 is what we're going to have to use. So our sine x is the same as the sine of 30, and then we've got to change it using our cast diagram. So we are looking at sine of x, so that's going to be, sine is opposite of our hypotenuse, so that's a half. And our cos of x for the 30, or the pi over 6, is going to be the adjacent, so it's going to be root 3 over 2. And because we're in this quadrant here, this one, because that's where we are, that's where 150 degrees is, we know that our sine is still going to stay the same, so the sine is going to be positive, but our cos has got to be negative. So we can substitute that in, so we have 12, and then we're going to have a half squared, because sine of 5 pi over 6 is a half. And then we're timesing that by the cos of x, which is minus root 3 over 2. So a half squared is a quarter, times that by 12, we get 3. And then we're timesing that by negative root 3 over 2. So we get minus 3 root 3 over 2, and that's our answer. So your marks for this question are for starting to differentiate, so this first bit, and then completing your differentiation, so times them by the cos x, and then evaluating it, so putting everything in, you get that last and third mark. Okay, so question 11. If we're looking at part A is an entirely explanatory question. So we have been asked to explain why the function f of x is never decreasing. So we've got y equals f dash of x as our graph. And we should know that y, or the f dash of x, so the differential of anything, gives us our gradient. So we know that m is equal to the f dash of x. So because the graph doesn't go below the x-axis, that's telling us that our gradient is never negative. And a negative gradient tells us that it's decreasing. So we know that there's no decrease whatsoever. So we can state that in a sentence. So as the graph of f dash of x represents the gradient of f of x, and the graph is always greater than 0, the graph, or the function, is never decreasing, is always positive, so the function or the graph of f of x is never decreasing. So that's all just about kind of understanding that you know that m is equal to the f dash of x, and because the graph is never negative, that means that the gradient's never negative. So it's asked us on a graph of y equals f of x, the y coordinate of the stationary point is negative. Sketch a possible graph. So the two things we know about the graph are, we know that it's always increasing, so that means that it can't be a kind of cubic that looks like this, because there our gradient is negative, so it can't be like that. So our turning point on our f dash of x, it's got to be a point of inflection rather than being a kind of turning point or anything like that. So it's got to be that point of inflection. And so we've been told that the y coordinate of the stationary point, so the stationary point is kind of in here, is negative. So we've got to have our stationary point being less than 0 and going up. And as long as we kind of mark our x, our 0, and our y, we're good. So the marks for this are stating explicitly for the first part that you know that because it never is less than 0, that means that the graph is never decreasing. And then you've got to plot your stationary point in the fourth quadrant, so down here, so because it says it's negative, and in the graph up the top here it's a positive x, so that means it's got to be a positive x and a negative y. And then your other point is for having a point of inflection on the graph that's always increasing, so making sure that you've not actually drawn something that's the wrong shape, something that's got a decreasing gradient. So we're on the last question of the paper one. We've got here, we have to determine the period of the function that we've got. So we know from the period of these graphs, it is this bit here that tells us kind of part of what we need to know. The period is how long one wave takes. And that bit there is actually telling us how many waves we have in 2 pi. So we know that in 2 pi we have 100 pi waves. So that's an awful lot of waves in 2 pi. So to find out how much one wave takes, we have to divide 2 pi by 100 pi. So we can cancel out. Pi's top and the bottom, we can cancel them out. 2 over 100 just cancels down to 1 over 50. and we can leave it as that, or you can put it as a decimal of 0.02. That's fine as well. Okay, now on to part B. So we've been asked to find the first 3 times for which v of t equals minus 60. So we need to equate these. So we've got our value of v of t is minus 60, but we have that v of t is equal to 120 sine of 100 pi t. So we can set them equal, so we get minus 60 is equal to 120 sine of 100 pi t. So we rearrange. We're trying to just find what sine t is. So we divide by 120 to get sine 100 pi t equals negative a half. 60 divided by 120 gives us a half. So that's what we've got. We now need to find and solve for this. So sine is negative a half. If we think about this in our graph, so we're going back to our CAS diagram, so our ASTC. So it's going to be negative a half in the thirds and the fourth quadrants. So that's like if we drew our sine graph, the sine graph doesn't come negative until kind of third and fourth parts. So we've got what it's equal to, it's negative a half, so we're going back to our exact value triangles. We've got the 1, we've got the 2, we have the root 3, and in this one here, we know that one's pi over 3, that's pi over 6. So we have a half, and it's sine, so sine is opposite over adjacent. So to get that, so it's going to have to be the opposite over adjacent to get us a half, so it's the sine of pi over 6, which is equal to a half. So in our third quadrant, it's going to be, so we have to add that to pi, so we're going to get 7 pi over 6, and in this one we're going to have to take it away from 2 pi, which is going to give us 11 pi over 6. We've been asked to find the first 3 times, so we can add another 2 pi to this first value, because that's when it would come round again. So if we add 2 pi to that, we would get 19 pi over 6. So those are our 3 values that we need to do. And that gives us, so 10 or 100 pi t is equal to the sine to the minus 1 of negative a half. And that gives us 100 pi t is those values that we got, so the 7 pi over 6, the 11 pi over 6, and the 19 pi over 6. So we have to divide them all by 100 pi. So we get 7 pi over 6 times 100 pi. We get 11 pi over 6 times 100 pi. And we get 19 pi over 6 times 100 pi. So the pi's cancel out on the tops and the bottoms, and that's us. So we get 7 over 600, we get 11 over 600, and we get 19 over 600. And because the tops are all prime numbers, there's nothing we can do to cancel anything out. So that's us finished with that question. So that's our first 3 times at which, or the first 3 times, and they're all in seconds because it's a time. Okay? And so for this question, it's worth quite a lot of marks. For part A, you get a mark for knowing how to find the period, so knowing that it's 2 pi divided by 100 pi, and then 1 for the correct answer. In the second part, you get 1 for equating your function with minus 60. You get 1 for rearranging. You get 1 for solving for the 100 pi t. You get 1 for knowing to use to find the one in the third quadrant, so knowing to add the 2 pi here. So getting that one, and then you get your next mark for having your values and getting your processed values, so kind of going through getting these ones. And then you get 1 mark just for knowing and getting your third value. So the first 2 get you the 1 mark, and then the last one, or the third value, gets that last one. Okay, so thank you all for watching. This is the specimen paper all done for paper 1. Paper 2 will be up as well. If you've got any questions, don't hesitate to leave a comment. That's fine. And hope you've enjoyed it. Hope it's been helpful. And thank you.